This lesson is on the binomial theorem, and there are some fairly challenging things in here, but it can also be fun too, for some reason. So on your formula sheet, these are the two formulas that will be given to you, and I blew them up a little bit. It's kind of hard to see. That's an n right there. That's an a to the n. And so the binomial theorem is another way, it's still the expansion that we did with the Pascal's triangle. It's the same exact thing. It's just that instead of using Pascal's triangle for the coefficients, we're using the binomial coefficient, which is the n choose r. And so, okay, well here it is expanded out, and you'll notice that this is the second term right here. And on the second term, the r, because the r is right here, the r is 1. Because here's r, so the power of the b is 1. So on the second term, r is 1. And that's really important to notice. And also remember that we have n plus 1 terms. This term right here is the general term. It's kind of like the formula for each term. And then this is, that should be b to the r, or is that? No, that's b to the n, sorry. The binomial coefficients are n choose r, and then we know that formula, we've been working with that, and so there it is for you. Also, let me see, what else? So it's important to know this. Also you can also write, this is not necessary to know this, but it's just helpful. You could also think of, because these are all sums, you could write it as the sum. From the first r is 0, because this is r of 1, and then this is b to the 0, so r is 0 to start with, up to n of n choose r. Basically, it's just going to be the general term here, a to the n minus r, b to the r. So that's just another way of writing the binomial theorem. Okay, I'm going to be referring back to these formulas a lot, and I recommend that while you're doing your homework that you have these formulas out in front of you. So here's our first example. We are going to write down the first 3 and the last 2. Terms of the sequence 2x plus 1 over x to the 12th. And this is a fairly complicated one, which is good, because if you can do this one, then you can do the easier ones as well. So essentially what we're doing, when you write the first 3 and the last 2, you're pretty much showing the whole sequence, because obviously you don't write every single term, because that would be really repetitious. So the very first term, again, I'm going to be looking back at that binomial theorem, so have that out handy. You'll notice the very first term is just a sub n. So that's a is this one, and this is b. So a sub n would be 2x to the n is 12, plus, and then it's going to be n choose 1. So just write, n is 12. So 12 choose 1. And then it's the first, or the a, and it's minus 1, so it's down a degree. And then this b is to the 1 power. I can put the little 1 there. Plus, and then they want the first 3, so then the next one will be 12 choose 2, and then a will be to the 10th power, and 1 over x will be to the squared. Those are the first 3, plus, and then we'll do the dots, and then plus, and then we'll do the last 2. And I like to go to my very last one. So the very last one is just n choose, it's 12 choose 12, but it ends up just being a coefficient of 1 here. So we don't even have to write that. And then the b will be raised to the 12th, and the a won't be raised, it'll be raised to the 0, so it's not going to be represented. And then the one before that would be 12 choose 11, because this one will be 12 choose 12. This is 12 choose 11. And then 2x would be to the 1 power. And b, the 1 over x, would be to the 11th power. So I'm just going to kind of step back and make sure that looks good. And that's how you would do that one. And by the way, we are just looking for the pattern, so we don't want to simplify it. Just leave it as is. You wouldn't want to make a mistake simplifying and have the pattern correct. Example 6. We're going to find the 7th term. And this is a very common problem. It'll be on the chapter test. It'll probably be on the IB exams. And see, what they'll do is they'll give you some big one like this that would be, oops, that's to the 14th. That would be really time-consuming and tedious, very time-consuming to do with Pascal's triangle. So they're essentially kind of forcing you to use the binomial theorem. And again, we're not going to simplify on this one. So, you have to be careful on this one. The 7th term, I'm going to go back to here. So, I do not like it when it does that. 7th term, what does r equal? Well, I know here my second term, r is 1. So, the r is 1 less than the term number. So that means if I'm on the 7th term, my r is going to be 6. And it's really important for you to notice that. So I know r is 6. And then because r is 6, then I can use the general term. So I'll write that down again, the general term, so I don't have to flip back to that page, is the n choose r of a to the n minus r times b to the r. So you'll be using that general term quite a bit as well. And now that I know my n is 14, so I've got 14 choose 6. My a is the 3x. 12 minus r, so 14 minus 6. And then b is the negative, put the plus and minus, the negative 4 over x squared, and then that's going to be to the r, which is 6. So 14 minus 6 is 8. Let's just go back and put that as an 8. And because we're not simplifying, we are going to leave it exactly like that. This is, like I said, I can't emphasize enough. It's really important that you know how to do these. They will be on our chapter test. They'll be on the AP exam, pretty sure. And you have to look back at your binomial theorem to figure out that the r is 1 less than the term number. Okay, now we're going to do example 7. Example 7 is pretty interesting. Okay, we're given x squared plus 4 over x to the 12th. And they ask us to find, there's two things we're going to find. The first one is the coefficient of x to the 6th. Okay, it's not just going to be, well, you can see you've got x squared here, and then x squared to the 3rd would be x to the 6th, right? Well, it's not necessarily the a to the 3rd term, because you also have 4 over x, and it's being raised to something as well. And that's going to affect the powers of your x's overall. So, it's going to be, you have to proceed very carefully on this one, because there's an x squared here and there's a 4 over x here. The best way, I think, to do this, the way that works for me, is to use some algebra. So, we're going to start with the general term again, and choose r of a to the n minus r times b to the r. And let's plug in what we know. So we know that n is 12. We don't know the term number that's going to give us x to the 6th. I suppose if you really wanted to sit there and try to figure it out, you could, but that kind of hurts my head. I'd just as soon do it this way. So we don't know r. We're going to find that, though. A is the x squared. We do know n is 12. We do know b is 4 over x. And we don't know r. But see, now we only have one unknown. And our goal is to, let me think about this for a sec. Okay, well, let's simplify this a little bit right now. We can simplify it a little bit. So we've got 12, choose r. We can, the power to the power, we can multiply the 2 to those. So that's going to be x to the 24 minus 2r. And then this is going to be, let's write this as 4 to the r over x to the r. And then we can, let's get our x's together. So that's going to be, because this is division, basically this is over 1, you can subtract. So we're going to have 24 minus 2. Oh, that's to the r. Why do I hate it when I make silly mistakes. That's not a 2, that is an r. Okay, that's better. I was going to say that didn't make sense. So I'm going to have x, and I'm going to have 24 minus 2r minus r using exponent rules. So that's going to be 24 minus 3r. And then times 4 to the r. So, sorry, I have to think for a second. Oh, yeah. Okay, sorry. We're trying to find the coefficient of x to the 6th, aren't we? So that means that we finally have got this all simplified. So we know that x to the 24 minus 3r is our x term, and that has to equal x to the 6th. Because the bases are the same, we can set the, that's an r, we can set the exponents equal to each other. So I'm going to come up here. 24 minus 3r is equal to 6. So if I add 3r and subtract 6 and then divide by 3, I get r equals 6. But we're not done yet because we actually need to find the coefficient of x to the 6th. So that means I can come back and come back to here, this formula right here, and if I put in 6 for my r, the coefficient's going to be made up of the 12 choose 6 as well as times the 4 to the r. So I'm going to come back, we'll go to a new color. I'm going to have 12 choose 6, x, this part actually really doesn't matter. I'll plug it in anyway, but we don't need to know it for this. That's going to be 3 times 6, which is 18. And then 4, well, yeah, we knew that was x to the 6th anyway. 4 to the r, 4 to the 6. So the coefficient's going to be 12 choose 6 times 4 to the 6th. And let's go ahead and use our calculator for that, because at 4 to the 6th we're going to have to use a calculator anyway. So I'm going to, okay, so 12 choose 6, I'm going to do 12 math probability, so arrow left, choose option 3, and that's 12 choose 6, enter, 924 times 4 to the 6th, 4 raised to the 6th, enter, 3784704. Okay. That's the final answer. That's the coefficient of x to the 6th. So kind of to recap this, you want to start with, you have to proceed with caution. You can't really just, well, I suppose if you tried hard enough, you could figure this out in your head. But it's still, at the end, you're going to need this anyway to figure out the coefficient. So you might as well just go through and do it with the algebra. So you're starting with the general term here. You will know n, you'll know a and b. You'll plug those in. You're going to use your exponent rules to simplify it, clear down to here. And then you are going to remember that you're looking for x to the 6th. So then you make x to the 6th equal to that. Solve for solve for r, get 6, and then come back and find your coefficient. Well, now there's a part B. They want us to find the constant term also. So let's see. I think I do want to keep a lot of this up here. So let's erase this. I still want my general term. And we'll go to a brand new color. How about red? This one's also tricky. So this is part B, find the constant term. This one's tricky. It's because of the 4 over x right here. It's not necessarily going to be the very last term when you do the binomial expansion. Now if this was a constant, then yes, it would be. But because this is not a constant, it's actually the constant term is going to be some other term in the sequence. And the way to figure this out again is to do the general term. So I know it's 12, choose r. We don't know r because we don't know which term is going to give us the constant term. And then a would be again x squared, the 12 minus r, and then b was 4 over x to the r. You know, I probably should have went back. Silly me. I should have went back because we have to simplify this all over again. Okay, if you go back up in your notes, go back up to where we got it to the point where you had 12 choose r, and we had x to the 24 minus 3r times 4 to the r. Go back to that. There's no sense going back through all that work again. And now, because we want the constant term, that means that, what's the power on x if you have a constant term? Well, there is no x, so that's x to the 0. So that means we're going to set x to the 24 minus 3r equal to x to the 0. And that will give us our constant term, our r value actually, that gives us the constant term. So 24 minus 3r will equal 0. Let's see, I'll add 3r, so it's going to be r equals 8. When r is 8, that's going to be a constant term. So, and they want us to actually figure out what that constant term is, so I'm going to be plugging 8 back in here for r. Let's go to a brand new color. 12, choose 8, x to the 24 minus 3 times 8. Yeah, I knew that, that's 0. That's a good confirmation though. And then 4 to the 8th. So this is 24 minus 24 is 0, x to the 0. So notice this is going to just go to 1, and we're going to have our constant term, which is going to be 12 choose 8 times 4 to the 8th. And again, we're going to want to go to the calculator to find that. Okay, 12 math prob 3 choose 8 enter times 4 raised to the 8th enter. Okay, and I've got that in my notes. So 32440 is actually the constant term. And you will get a chance to practice these in the homework. And there will be one on the test. And I kind of doubt the IB they're going to put this on the IB exam, but it's good practice, so I'm going to put it on the test. Now we only have one more example to go. Example 8. This one we're going to find the coefficient of x to the 5th in this one, x plus 3 times 2x minus 1 to the 6th. This one's not as straightforward either. You can't, it's a little hard to guess and check on these because the x to the 5th term, so you're expanding all this out, because you're also multiplying like this whole expansion by the x term. Oh yeah, when you expand this out and get the x to the 5th term, that's going to get multiplied to the 3. So you're going to get the x to the 5th term that we're looking for. Part of it's going to come from multiplying 3 to x to the 5th, and the other one's going to come from multiplying the x to the 4th term. So, and you're going to be adding those up and getting the final x to the 5th term. What I found helpful on this problem was to get a feel for the pattern. And what I did is I'm going to expand this and see what we get there. So there'll be an x plus 3 out in the front. And then if we expand the 2x minus 1 to the 6th, that's going to be, and you know, I think I probably, Well, yeah, we'll use the binomial theorem. Okay, so it's going to be, the first one has a coefficient of 1, so it's 2x to the 6th, and then the negative 1 isn't represented in the first one, plus, and then the next one is 6, choose 1, 2x to the 5th, and then negative 1, plus, and then the next one is 6, choose 2, 2x to the 4th times negative 1 squared, plus, now I think I was saying, I don't know that I necessarily need to keep going, but let's do one more. 6, choose 3, 2x to the 3rd, and negative 1 to the 3rd, plus, and I'm running out of space, but that might be okay. So the x to the 5th term is going to come when this x gets multiplied to the x to the 4th term. So this one times that will give you one of the x to the 5ths. And then the other one is going to come from when you multiply the 3 to this x to the 5th term. So I don't need to expand this any further because I have everything I need right here. All I need to do now is simplify each one of these and then multiply them by these numbers out here. So 6, choose 1. We could actually do that in our head. You could think if you had 6 things, how many ways is there to choose 1? Well, there would be 6. Or you could do the 6 factorial over 1 factorial, 5 factorial. And you'll see you'll get 6 doing that as well. So I'm going to have 6 from there times 2 to the 5th, which is 32, times x to the 5th times negative 1. So let's see, what is 32 times 6, 12, 1, 18, 19. Okay, so negative 192 x to the 5th is this term. And then over here, 6, choose 2. I'll use the formula. That's going to be 6 times 5. 4 factorials get knocked out. There's a 2 there. That 2 goes in there. And that's going to be 15. So 15 times 2 to the 4th, which is 16, times x to the 4th, times negative 1 squared, which is positive. 15 times 16, what is that? I don't even know. Well, it's going to be 225 plus another, now I'm going to mess it up here. I'll just do it. I don't want to make a stupid mistake. That's just silly of me. 15 times 16, 240. Okay, so 240 x to the 4th. Great. So now this x to the 5th term is going to get multiplied by 3 when you were, if you FOILed this all out the long way, which we do not want to have to do. Plus, we'll be multiplying x to this term at some point, which will also give us an x to the 5th term. And now we can multiply these together. So this is going to be 192 times 3, negative 576 x to the 5th plus 240 x to the 5th. And when you add those up, you will get negative 336 x to the 5th. So that means that the coefficient of x to the 5th is negative 336. So that was a pretty challenging problem because you had to use the binomial expansion. You had to kind of think about what's going to happen when you multiply the x plus 3 through, and the fact that you're going to have 2 terms here that will result in an x to the 5th term. Yep, and you'll get to practice these on the homework as well. So that concludes this lesson. It also concludes Chapter 7 as well.